Let's actually start looking at some problems now. So again, the key part here is making sure that when we are looking at our equations, they have to be defined. They need to be inside those restricted domains that we have. So if I look here, a lot of people just want to cancel these out and say the answer is 0.75. That works as long as we're inside our restricted domain. So for sine, and remember sine goes from bottom to top, 0.75 as a decimal is going to be somewhere in this section, so we're good. So this one actually is good. Our answer will just be 0.75, so we don't need to worry about that. Here, if we look at cosine of 3 pi over 4, well, 3 pi over 4, cosine is going from 0 to pi. 3 pi over 4 is right here, so that one's also okay. So our answer, we can just think of these as canceling with each other, and we just get 3 pi fourths back, which works. If we look here at inverse tangent, again on this one we get lucky, this one works. Inverse tangent and tangent, they are going to be in this half of the unit circle, and 1 falls within that domain, so we're good. So our answer would just be 1. So those ones are kind of the easier ones where everything works out, but we're going to look at some trickier ones. So let me slide this up. Hey, composite functions. So in unit 4 that we did, we looked at composite functions, but not trig ones, just regular functions, and that was where you would plug an equation inside an equation. So do you remember this notation right here? So this is saying G is plugged into F, or if you remember doing this little open dot, we would say F is composed with G. We can also do composite functions using trig functions, where we're plugging one inside the other. So when solving these types of problems, kind of similar to what we did in unit 4, we're going to start with the function that's inside and then work our way out. So on this equation, let me zoom in a little bit. We have sine of inverse sine of square root of 2 over 2. And so looking at our unit circle, one important thing to remember is inverses are backwards of each other, right? So when we use our regular trig functions, if I was just using sine, we would be plugging in an angle. I would say, what's sine of 30 degrees or pi over 6? And we would say, oh, we get this out. So this would be our input, this would be our output. For inverses, it works backwards, because remember, that's the definition of an inverse, is they're backwards from one another. So in inverses, you're going to start with the ratio. You're starting with this part, and you are going to get back the angle, either in radians or degrees. So if I'm starting with a sine, I'm going to go from here to here. If I'm starting with an inverse sine, I'm going to go from here and back to our angle. They're backwards of one another. So that's why this inverse sine is using the ratio square root of 2 over 2. So because it's an inverse sine, we know that inverse sine is only going to be between negative pi halves and pi halves. That's our restricted domain. So when I look at my unit circle, that's going to be this half of the unit circle, and we're looking to see when does it equal square root of 2 over 2. So sine, that's the second value, the y value in the ordered pair, it equals square root of 2 over 2 right here, which would be pi fourths or 45 degrees. So that's going to be our inside. We're saying this piece right here, and let's just work in radians, is equal to pi over 4. But then I have the outside still. I'm saying, well, then what's sine of pi over 4? So remember, we're working from the inside out. The inside is equal to pi fourths, but now I'm taking sine of pi fourths, which just happens to get us right back. If I take sine of pi fourths, we get back square root of 2 over 2. And that would just be your answer. So sometimes that'll work out where it's almost like these two are just canceling out. That would be like the shortcut, is just to say they cancel and this becomes your answer. But that isn't always going to be the case because of this restriction right here. And we'll show some of those in a second. Okay, so here's a couple more examples. See, we have a composite one. This time we're not using the same trig functions. We have a cosine and then an inverse tangent. And we're not using technology, so that means no calculators. So when we're doing these composite functions, remember we're going to start from the inside and then work our way out. So first thing we want to do is look at that inverse tangent of square root of 3. So again, I wrote down all of my tangents in purple on the outside of my unit circle. You might want to do that as well, just so you don't have to keep doing the math every time. But we're saying here's the inverse. We're saying here's the answer or the ratio. What's the angle that matches it? We're going backwards. So we want to know, when does tangent equal square root of 3? And I look around my unit circle. There's a couple places that it does. It does here, equal square root of 3 at pi thirds or 60 degrees. And also straight across on the unit circle, it equals square root of 3. So that would be 4 pi thirds or 240. So right now, if I look at this, we would have two parts, right? We'd have pi thirds and 4 pi thirds. But if we look at our ratio, or not our ratio, our restricted domain, remember tangent only goes from negative pi halves to pi halves. So if I'm looking just in this domain, pi thirds fits inside of here, but 4 pi thirds does not. So we throw that answer out and we only take the pi thirds. So that's again where that restricted domain comes into play, and you have to be really careful with it. So there's the inside. Now I want to know the outside. So now we're saying, well, what's cosine of pi thirds? And so that will just be a regular unit circle problem. We're just going to find pi thirds and see what the cosine is, and that's the first number in the ordered pair, so 1/2. And that would be your answer. Okay, let's try another one. So this time we're doing tan, and then so what's tangent of the inverse sine of negative 1/2? So again, we're going to start on the inside. Inverse sine, remember, only goes from negative pi halves to pi halves. So we really only care about that half of the unit circle. So we're looking at this half right here. We want to know when it is equal to negative 1/2, right? Yeah, negative 1/2. So if I look at my sine values, that would be right here. Again, here's the tricky thing with this quadrant. Because we're going to pi halves, instead of going around and thinking of this as being 11 pi over 6, we're reversing it. If this is 0, this would be pi 6, pi fourths, pi thirds, as I'm going around in the positive direction. We are now moving the opposite direction into the negatives. So if this is positive pi 6, if I go the same amount into the negative direction, this would also equal negative pi over 6. So we're going to take that answer, not 11 pi over 6. So again, I see that mistake quite a bit on this section, is students want to put 11 pi over 6 instead of negative pi over 6, which they share the same spot on the unit circle, but they're different numbers. 11 pi 6 will not fit between this domain. It's not between negative pi halves and pi halves. So we want this one right here. So careful with that. But then, so that's the inside. Now I'm saying, well, what's tangent of that? So if I go to negative pi 6, which is the same as 11 pi over 6, but if I go to this point, tangent, again, I wrote it in purple, is negative square root of 3 over 3. And so then that would be your answer. So just be careful. I'm going to put a little star here. This is not the same as 11 pi over 6. So we have to be careful with that. Okay. Let's do 2 more. Okay, so again, start from the inside, work your way out. So first we're looking at the inverse tangent of negative 1. Again, inverse tangent is going to use the right half of the unit circle. And so if I look at my purple values, we're seeing when does it equal negative 1? That's going to be right here. But remember, this is not 7 pi over 4. We're going backwards. So if this is positive pi over 4 and I go the same amount, this would be negative pi over 4. So instead of 7 pi fourths, I'm going to write negative pi over 4. And there's going to be the inside. But then now we take the outside part. So cosine of negative pi over 4. I go back to my unit circle. Negative pi fourths shares the same place as 7 pi over 4. and the cosine value is square root of 2 over 2. And so then that would be your answer. But remember, this part, it's not the same as 7 pi 4, so we need to do the negative going backwards. Okay, then this one, we're starting again on the inside. This time we're doing the regular function first and the inverse second. So on your regular functions, there is not a domain restriction or anything. We're just saying what is cosine of 3 pi halves. When you have your regular trig functions, they give you the angle and they want back the ratio. So they're telling us here's our angle, 3 pi halves. What if I go to that on the unit circle, what's cosine for that? And that value would be 0. So we're saying here's 0, but then now we do the outside part. We have the inverse sine of 0. So here again is where we have to be careful on our domain. Inverse sine is only using this half of the circle. So our sine value will equal 0 at this point on our unit circle. So this kind of counts as two options, right? We say it's either 0 pi or 2 pi, but 2 pi does not fit between negative pi halves and pi halves. Only 0 does. So we're not going to take the 2 pi part. We're just going to say it's equal to 0. So again, careful with that. We can't go outside of our domain restriction.